Hello all, the time is now 6:05 p.m. So if other participants join, they'll join. Let's just start the session. I hope my screen is visible. So yeah, welcome to week 11 of problem solving through programming in C, live NPTEL interaction sessions. So let's just start with a recap of week 11. So first we looked at interpolation data. So if we have, if you know the value of values of a function at different points, we can interpolate. We can get a value in between. I mean, between two known values of that function using interpolation. And if we want some value which is not in the bounds, which is outside the bounds of those points, then we can use extrapolation. Okay, so there are two terms, interpolation and extrapolation. So extrapolation is where we find something which is not there in our boundary. Okay, we basically predict using the data that we have. Then we saw numerical integration using trapezoidal method. So trapezoidal method uses this fact that a curve can be split into multiple line segments, and so integration is basically the area under a curve within certain limits. So here numerical integration, it always it is useful only for definite integrals. So where we have two limits and we integrate within those two limits. Okay, so same thing happens when we find area under that curve. We have two bounds and we have a curve and we find its area. So trapezoidal method uses the fact that I can split a long line into a long curve into many short line segments, and I can and each line is, I mean, each line, if I draw two parallel lines like this, two vertical lines like this, I will get a trapezoid. So, and I know the area of a trapezoid, so sum of those areas will be the total area. So trapezoidal method uses that. And then we briefly we saw how ordinary differential equations can be solved using fourth order Runge-Kutta technique. There is also second order, and there are many techniques, so if you are more interested you can go through it at your own pace, own time. And then recursion was done properly. So in earlier weeks, maybe, I mean, when functions were introduced, recursion was shown in a way, and but in this week it was properly implemented on how, on like what it is, how to use it, etc., etc., its pros, its cons, all those things. And then stack, so operations related to stacks and how we can make recursion more efficient using stacks. Okay, so stacks basically, one example for stack is you're at home making, let's say, either chapatis, dosas, or whatever. You have made like 5 or 10 of them and you store them in your casserole or some vessel. So the one that you make first will be at the bottom, but when you will take the top one first, right, which came in last. So it is last in first out. This thing is last in first out. There is one more thing just for your information. One more, so stack is a data structure. Okay, so we have pop and push. So we push an element in and then we pop an element out. So those are the two functions that are there. Okay, so not functions, operations related to stack. One more data structure example that we have is queue. So queue. So queue, you might know queue from like standing in queues at the bank or at the grocery store, supermarket, wherever. So queue, whoever comes first goes out first. So that is first in first out. Stack is last in first out. Queue is first in first out. So queue follows an order. Queue follows a decorum, right? Stack is different. But stack is useful in recursion, because in recursion we start from the back. We if you want, let's say, recursive value of 5 and our exit condition is there for 0 or 1, just for example, just let's say factorial. So we'll reach 1 or 0 last, but we'll give its output the first. So 1 or 0 we have reached, then we so first 0, then 1, then 2, then 3, then 4, then 5, like that. So here stack is more useful because of its because of recursion's last in first out nature. Okay, so then basics of structures are given. So structures is what we use for combining multiple data types into one single data type. Okay, so proper syntax will be covered in the next week. I mean, if you have watched it, it's great. So I think in this week only how to define a structure was covered. So next week, how to call a structure, how to implement operations on a structure, how to target a specific element, not element, or I'll call it element only, specific element in a structure, like that. You will see all that. So let's start with the problem. So first we have Lagrange interpolation. So I have a function f of x and I know its values at x equals 5, 10 and 15. So it is a basic math problem that you can easily do. So just give it, clock is open. So just note it down, but it will be there on the screen anyway. F of 5 is, the value of function at x equals 5 is 16.22, f of 10 is 10.97 and f of 15 is 1.41. So it is gradually decreasing from 5 to 10, but then it steeply goes down after 10. Okay, so you can see the difference. So I want the value of f of 11. So I'll give you 4 minutes for this. Okay, so polls are for some reason Google Meet seems to have removed polls. So because of that I can't give options in polls. So but just see to it that you can. Yeah, I need 3 decimal places. Okay, so make sure you have a calculator next to you, and I have already started the timer. So just So time's up. Let's just the chat is open, so you can write your answers there. So what I'll do is let me just stop sharing this. Yeah. So I am using a different device to write. So just I hope you can see the screen. So yeah. So here what I know that is f of, let me just, sorry. Yeah. So what I know that is f of x at x is equal to 5 is this horrible, right? F of 5 is 16.22, f of 10 is 10.97, and f of 15 is 1.41. Okay. So what I know that, so if I use the formula here, I need f of 11. Right. So if I use the formula here, what is the formula? So I have three values of x that I know, x0, x1 and x2. So I need xn or xj, whatever. So L0 of x, I'll just write the formula for one, then I'll directly write the values for the others. Okay. So what is pi? Pi means product, right? So j equals 0 to 2, because there are only so 0, 1, 2, right? 3 points, and of course j not equals 0 here. One more condition is there for the 0th term, technically the first term. So it's basically x minus xj by x naught minus x, it's not I, it's j, right? So product of this, I mean of all these j terms. So so first, so these are coefficients, okay? These are coefficients for the values 16.22, 10.97 and 10 and 1.41. So x is what? X is 11, right? So 11 minus 11 minus 10 by 5 minus 10 into 11 minus 15 by 5 minus 15. So this is equals, yeah, 11 minus 10 is what? 11 minus 10 is sorry, yeah, 11 minus 10 is 1 into minus 4 by minus 5 into minus 10, right? So I have 4 by 50, so I will cancel this. This is 5, this is 2, so I have 2 by minus 2 by 25. So L1 of x will be, I will replace all, I mean same thing, but instead of x0 I have x1, and of course and j can't be 1. Okay, so this is 11 minus 5 by 10 minus 5 into 11 minus 15 by 10 minus 15. This is 11 minus 5 is 6, 6 by 5 into minus 4 by minus 5. So this is plus 24 by 25. And lastly I have L2 of x, which is 15 minus 5 by 11 minus 5 by 15 minus 5 into 11 minus 10 by 15 minus 10. This is nothing but oh God, there is something with the screen. Yeah, this is nothing but 4 by 5 into, this is 6 by 5 into 6 by 10 into 1 by 5 is equal to 6 by 10 is 3 by 5, so 3 by 25, right. So I have got all the three coefficients. So now all I have to do is scrolling is insane. So yeah, all I have to do now is just take the sum. So what is so I have all the values here, right, easy. So and I know the values of that function as well. So f of 11 is equal to L0 into f of 5 plus L1 into f of 10 plus L2 into f of 15, right. So sorry for the bad handwriting, I'm not very used to writing on screens. F of 5 was, L0 was what, minus 2 by 25, right, minus 2 by 25 into 16.22 plus 24 by 25 into 10.97 plus 3 by 25 into 1.41. So if you guys can quickly calculate this, or I'll open the calculator on my own computer, right. So 24 into 10.97 plus 3 into 1.41 minus 2 into 16.22 divided by 25. So it is 9.4028. 9.4028 is f of 11. So I hope you got that answer. Since the denominator was 25, we didn't have a really repeating uh, decimal point, because it's a multiple of 5, so it will terminate very fast. So yeah, this was it. So let's just okay, sorry. I will stop sharing now. This I'll share on my own screen now. Okay. So I hope you guys were able to do it. I mean, I hope your answers matched, because no one wrote on the chat, and as far as I know, the chat is still active. So whatever. Without wasting any more time, let's go to the second one, recursion. So what is the output of func 1025 comma 2? So my function is this unsigned int. So one small mistake, it automatically made it caps. So yeah, so sorry, yeah, unsigned int, right? So I am taking into integers n and r. Okay, so I have my exit condition as this else. So if n becomes 0 or less than 0, I will exit. Okay, so I'll give you even here I'll give you 4 minutes. So this I will not write the whole code, I'll just write the whole code. It's not too much effort. So we have received an answer, it is 2. So let's just find out what the answer is. So I have yeah, I hope the screen is visible. Okay, so I have just written this code, right? So function is this, and instead of writing unsigned, I just gave normal integers. Okay, so even here my main is just calling that function here, and I have already given these inputs 1025 comma 2. So I'll run, and like Shreya Prasad answered, it is 2. Okay, so let's see like what is happening here, right? So I will just write here itself. So I'll start my comments, end my comment here, right? Okay, so first inputs are 1025, n is equal to 1025, and r equals 2, right? So sorry, yeah. So since both are integers, this division will be rounded off to the floor, I mean lower integer, right? So 1024 by 2 is sorry 1025 by 2 is, so first this thing, right? So it is returning this thing, what is it called, modulo r, right? So 1, since it's odd, if I take the remainder with 2, it will be 1, and then I'm calling the function again, and the new values are 512, right? Because 1025 by 2 is 512 comma 2. I'm doing this again, 1 plus, and this thing 512 mod 2 is 0, right? Because it is a multiple. So plus func 256 comma 2, right? Now I'll do 1 plus 0 plus 0 plus func 128 comma 2, great. So 1 plus 0 plus 0 plus 0 again, func so this number was just one above than power of 2. So until we reach 1, we will get all zeros. So once we reach 1, this thing, this n mod r will be 1, and this thing will be 0, right? N will be 0. So this condition will fail. So for completion's sake, I will just write this. So this becomes 0. Copy this. (32, 2). (16). 8. 4. 4 2 and 1. Alright, and yeah, just these zeros are extra zeros are there, so this will make this one and mod I'll get 2, right. So I'll just copy all this. So 1 plus a bunch of zeros plus 1 plus func of 0 comma 2, right. So this is 0, this is one exit condition, right. So it will this thing is 0, so I'll get 2 equals 2. So here if I have something like let's say instead of 512 I take sorry, instead of 10 I take some value, let's say 96, because why not. Okay, so 3 and 1, so it is 3 and 1 that give me 2, right. So I'll take 47, 5, right. So every odd number that I get, I will get a 1 for that. Okay, so 47 is odd 1, 47 by 2 is 23, so one more, so 2, 23 by 2 is 11, so 3, 11 by 2 is 5, 4, 5 by 2 is 5 by 2 is 2, 0, 2 by 1 is 1, 1 is odd, so 5. Okay, so for every odd number I'll get 1 plus 1, because the last number is 1. Okay, so I hope this was clear, this recursion. It was just a small example. Okay, so now let's move on to something a little more challenging, shall we? Oh yeah, so before we do that I would like to introduce you to Simpson's 1/3 rule. So there are many rules here in Gauss quadrature. So first one was trapezoidal, where I said that it uses the fact that a long curve can be split into many small line segments. Okay, and for each line segment we can find the area. Okay, so if so in the same way this thing uses, so instead of splitting the curve into multiple line segments, we split it into multiple parabolas, whatever is correct. Okay, so to make a line we need 2 points, to make a parabola we need 3 points. Okay, so here I have so this is the function, this is the parabola. Okay, so and area of a parabola also I know more or less, so I will not go into the details of the derivation, but I will just tell you the formula directly and one condition that has to be followed. Okay, so one main condition that has to be followed is number of segments has to be even. So if it is odd, I will not I will not get my parabola will not be complete. Okay, so number of segments have to be even, so n is the number of segments that has to be even, and h is the size of each segment, right. So h so just give me a minute. Yeah, so h is the size of each seg, so I'll explain the formula once, right. So f of x dx, so f of x and y are same, so here to save some space I wrote y, I should have changed it to y here, but you or I should have made it y of x dx, whatever, a to b, so my limits are a to b, y0 plus yn. Okay, so y0 and yn, so first and last term I will take as is, yeah, and I will multiply the whole thing by with h by 3, h is the step size as in length of size of each segment, not segment, each bracket, each how do I put it? So m minus a is h, b minus m is also h. Okay, so just keep that in mind. So this is there, and all the odd ones, right? So y1, y3 up till yn minus 1. So since n is even, right, because number of segments are even, number of so here I have 2, right? So 0, 1, 2. So b is even. I have split it into 2. So n minus 1 will be odd and n minus 2 will be even. So all the ones that are odd values, not values, odd y's will get multiplied by 4 when you add them, and all the even ones will be multiplied by 2, and yeah, except the last one, of course. Last one will be added as is. First one or the 0th one will also be added as is. So this is basically the case. Okay. Yeah. Okay. This is the gist of the technique. So like I said, the more complex the curve is, the better result we get. Okay, so if I want straight lines to give me an accurate answer, then I'll need many segments. But if I have one curve, I'll reach a little more accuracy with less number of splits segmentation. Okay, so you have the formula in front of you. I'll just take a minute's time and write it down. Okay, just note it down, or I'll show the task and then I'll come back to the screen. Okay, so task is basically to write a function. Okay, not function, you can just implement it in directly in the code itself, in the main itself. 6 intervals, fine. So the bounds will be user defined. Oh, I didn't write that. Okay, so right, so bounds will be user defined. Okay, so this is the function. We used the same function last time for something else, so I didn't change the function. And once you do that, we'll also compare the result by integrating it ourselves. Okay, so you this is the formula, right? So just write the main for this, then I'll change it to this slide so that you can write a function for this and call it small function just for this. Okay, so I'll give you 15 minutes for this. I think it should be enough. So I have started the timer. Okay. I hope you remember integration by parts. Okay. Because that is what we are going to use. Yeah. Right. Okay. So integration of parts, if you don't remember, it's fine. I'll just tell you what it is. So if I have u into v dx, this is nothing but u into v dx minus du by dx into v dx whole thing dx. Okay, here. So basically u dv minus u dash dv. Okay, so this is the thing. So what function do we have? We have a slightly long function, that is f of x equals x e power 2x okay minus 3x square plus 2. So you also have rules for v and u that choose a function that is, choose v as a function that is better than, something. I don't remember that, but I will go with my intuition and say that x is u and e power 2x is v, because because du by dx makes it is 1, right? So then I'll not have a propagating integral. Okay, so so integral of fx dx, I'll add the limits later. Okay, so equals, so first I'll take this term. So e power x 2x integral is 2 into e power 2x, so I'll have x into 2 into e power 2x minus integration of du by dx is 1, so I have again 2 e power 2x dx minus 3x square. So integration of 3x square is x cube, right? No, 3x cube by 3, so x cube, correct. Plus 2x. right, integration of 2 is 2x. So this will give me 4 e power 2x. So I have basically x 2x e power 2x. I'll write it in the next page, or wait, I'll write it down. This is 2x e power 2x minus 4 e power 2x minus x cube plus 2x. Okay, so limits, since I am splitting it into 6 parts, I will take it as some multiple of 3. So let us say the limits are 6 and 9. Okay, 6 and 9 would be too much. I would take, since I have e power, right, so e power, if I take power of 9 and all, that will be insanely high. So I will take something as, let us say, I can take 1 and 3, sorry, I can take 0 and 3, right, 0 and 3 is what I can take. So value of f of, sorry, this thing at 0 is equal to first term 0, second and third and fourth term 0, so only minus 4 is left. And if I substitute the value of 3, what do I get? Just use my calculator to calculate. So I'll get 2x is x6 into e power 6. Oh, this is also very, very, very high. Or what I'll do is I'll take 0 and 1.2. Okay, so so I can split it into 6 segments, and each of them would be 0.2. So h is 0.2. Okay, h is 0.2. So e power, so 1.2 into 2 is 2.4. 2.4 into 2.4 into e power 2.4 minus 4 into e power 2.4 minus 1.2 cube plus 2.4, right. So I have a lot of 2x. So what is e power 2.4? 2.4, 11.023. So into 1.6, 17.63. So I have minus 17.637 plus 2.4. So right. So minus 1.2 cube plus 4, right. So this minus 4 will become plus 4 because I am subtracting this, so it will become plus 4. So I will also do this. So I have minus 11.237. So minus 11.237 minus 1.2 cube, right. So 1.2 cube is 12,144 or 1728. I will just calculate 144 into 12. Yeah, 1728. So 1.728. So 1.728 plus 11.237. So I get minus 12.965. So that is what I should get. So I will write this on my presentation so that, or I will just, okay, so I will stop sharing this. Sorry. So for some reason this yeah. So I have stopped sharing this. Also remove the device. So yeah, let's quickly write the code and see. So I hope the screen is visible again. I'll remove all this. Right. I'll define the function as a float f of x, and this is, yeah, I have to include math.h as well. So what was my function? My x into wait, just give me a second, I will okay, so I am using the right thing, right? It was x into e power 2x, right? So 2 into x. Obviously, you have to use star and not dot like me. So x into e power 2x minus 3x square. So 3 into x plus 2. Right. So this is done. My function has been defined. So then int main. I'll write the whole Simpson's rule here itself. Okay. So interval a and b. Okay, so this also has to be float because I'm taking 0 and 1.2, right? Float a b, float h, a, b and h, right? So h is the step size, of course. So def enter a and b limits. So I have entered this. So enter. So number of sub intervals, I know it is already. So number of sub intervals is 6, right? Number of sub intervals is 6. So to calculate the step size, that is h. So h equals, or I'll do one thing. I'll print it. Number of sub intervals is 6. Okay. So h should be basically b minus a by 6, right? So b minus a by 6. Okay, easy. Nothing much till now. And yeah, so the actual integral, right? I'll just call it integral integral. Okay, so I'll set it to, okay, so here, so like we saw that it's a summation of many values, right? So I'll initialize this to be 0, then I'll start. Okay, so I'll start adding. So initialize, yeah, I can initialize this to 0, or I can just initialize this to yeah, I will just initialize this to 0. Okay, so now I can say integral, or no, instead of doing this, I can right away just add these two values, I mean the boundary values, right? So h, so h by 3 into f of b plus f of a. So this I know, right? This is what I know. Now I'll take in the value for other these things. So so 6 is the number of partitions, right? So 1 to 6. So wait, let me also include k here. I will use k as a flag here. So k equals right. So a, the lower bound, plus I into step size, right? So yeah, so next, so if I start with 0, my first one will be 0.2, then it will be 0.4, 0.6, 0.8, right? So I into step size is h. So k is the step, right? At what value I am at, that is k. So for what value I need to calculate f of x, right? So yeah, so now what I say, and 6 is the final, right? So a plus 6 into h will be b. So I am not reaching b, I am stopping myself at this thing, yes or no? So so that is why what I'll do is, if, so that is why I am only traversing. So in our case, my inputs will be 0 and 1.2. So I want, inside the loop I need only the values for at, not for at 0.2 to 1. I mean 0.2, 0.4, 0.6, 0.8 and 1, because I have already included the values at 0 and 1.2 here, right? So if so I'll say for odd and even, right? So if I do equal to 1, I mean I can say not equal to 0, or I can say equal to 1, because you will only get two types, right? So it doesn't really matter, right? So I have integral here, instead of doing this each time h by 3, what I will do is I will remove this from here, I will multiply it at the end. I think that is better, right. So integral equals integral plus 4 into f of k, right, else integral equals integral plus 2 into f of k, yes or no, because because all odd ones are supposed to be multiplied by 4 and even ones are supposed to be multiplied by 2. And finally, I will multiply it with the step size. Integral equals integral right, yeah, into h by 3. So that is done. So now I will just printf integral in the limits s a, b and integral. So let us see if it works and if the value is correct. Why is this giving me an error? Yeah, so sorry, my bad. I should have done this with hash define. I did not do it with hash define, that is my fault. For some reason I defined it like a function float. Limits are 0 and 1.2. So I got 4.7821 and what did I get? Sorry. So I got a huge error. I think it will be better if I had taken some easy thing as a cubic number or something. So because this error is huge, I got minus. Yeah, why did I get minus? Yeah, I got 12.965 when I did it by hand, and when I solve it here, I got 4.7821. So there seems to be some error. So let's just try the same thing with an easier function, right? Like 1 by 1 plus x square. Does anyone remember the value of 1 by 1 plus x square? Or never mind. If you have any doubts here, let me know, else I'll proceed. So we got a big error because the number of splits were or what I'll do is I'll change this to, instead of 6, take 18, and I'll say if I yeah, now I'm thinking maybe I made a small mistake in doing it by hand, because first of all it should not have been negative, but anyway. Uh, so yeah, this way if I increase the number of gaps, I can get better answers, 0 and 1.2. See, with each time the answer is changing, because it is not a regular curve, so it's very hard to find its area. So I'll just make it 360 and see what happens. So it will take a lot of time, because yeah, so it is still oscillating, right? So I hope you understood how we got the answer. Okay, so this is, hoping this is clear. Yeah, lastly, so we are back to recursion. Write a function in C, I mean function and the whole program to reverse a string using recursion. Okay, so in the so you have to use a recursive function to reverse a string. Okay, so give you 12 minutes here, and then I'll like start writing the code. So yeah, if I input, let's say, dinosaur, I should get the reverse. the sound was not being recorded, so I'll just repeat it one more time. Why I didn't get correct answer while writing was because I took the integral of e power 2x as 2 into e power 2x, whereas I should have taken it as e power 2x divided by 2. Okay, so that was one mistake I made. That is why I got minus 12 point something something something. And so if I take a very large limit, I'll get my answer will be close to the actual answer of 4.78. Else, when I started with 6, as so 6 as in I'll only calculate at 0.1, sorry, 0, 0.2, 0.4, 0.8, sorry, 0.6, 0.8, 1 and 1.2. That gave me very bad answer. That gave me 3.03 or something. So, okay, so just keep that in mind. Back to the task in hand, I guess. So time is up. Let's quickly run to the program. I hope you tried and I hope you got the answers. I hope it worked out. But in essence of time, I'll just directly write this. So I'm deleting all this. Oh God. Screen is visible, that is cool. Right. So we know that we don't need math.h. Do we need string.h? We don't need string.h because we are not using strrev. That is an inbuilt function string.h. We are not using that, so we will not be needing that, right? So I'll just predefine the function here as function prototype, or I'll just write the whole function here because why not, right? So since I'm passing an array, I'll just give star to the name of the function, right? So if I was writing a prototype to make sure that it's an array, I'll have to do this, that's all. But I'm writing the whole function here, so I will I'll just call it str, right? So sorry. So function, huh? So yeah, so I have called static here because if I change the value outside the function, I don't want it to affect. I don't need to write static, but I'll anyway write static for the sake of it. Or let's see what happens if I don't write static. Right, just write char. So I need some max. Okay, so so size I'll anyway define here. So in main I will define that here anyway str 100, but this 100 I don't know if that is also 100, right? So I need a global variable, and let's call it max. So max, or yeah, max len, this is 100. So I have defined a global variable like this. So instead of this, I'll change it to max len. So that way it will know that it's the maximum possible length is 100. So, and of course I'll also use pointers here just for the sake of it. So I'll take the input from the user, printf, enter a string, right? So yeah, I don't have to put an ampersand here because it's an array. It's a string. Okay, it's a whole string at once. If I would enter it element by element, then I would have to use ampersand. But since I'm inputting it as one, I don't have to do that. Okay, before continuing with the main main function, I'll write the smaller function. So even this rev, I'll call it so I'll define one more a character here. Okay, just a smaller string rev. So this will get stored in the larger one. So I'll explain what is going on once I finish writing. Okay, so give me a minute for that. Even this I'll define it as max len, obviously. So if it exists, so we are using the stack function of recursion here. Okay, so I'm traversing through the end. So if will be false if I reach the end. Okay, so that way only rev will be left, right? I mean only this thing. I am storing my string here in rev, okay, at each point. So I'm using the stack functionality of recursion. So whatever enters last will leave first. So here the last character will enter last and it will leave first. So that is how I am using recursion for this, but once I finish writing you will understand it better, and of course we will see if it runs first. So sorry, so I have taken the input here and yeah, I am giving star rev here because I want rev to point at the memory given here. Okay, so this I have written. Then finally printf why not reversed string is percentage s comma rev. So I am storing the reverse of the string in rev. Okay, so rev is a variable, a string variable where I am storing the reverse of the string. So did I make a mistake here? Return rev. In function rev, function returns address local variable. Oh, but it's still running. I stopped it. Yeah, so this I had made a small mistake here. Sorry about that. Oh, so enter a string. Reverse string is null. So it's again null. So I think Yeah, some values are changing outside. Ah, okay. So if my, oh, okay, I'll explain it to you. So since this function itself is a pointer, this is dynamic. Okay, so you'll learn this more in pointers. So this part is dynamic. So I have to mention that these are static to make sure that they are static. Okay, so dinosaur. Okay, I got the reverse. It works. The function has worked successfully. So, so what is going on here? Right. So first, I have defined this called a function char called river to reverse my string. I take this string as input, right, and I have since it is a dynamic function, I'll whatever I don't want to change much, I'll define that as static int and static char. Okay, so this rev is what I am returning to this. Okay, so if star str means if the starting address of the string is not 0. Okay, so string is an array, so it is passed as address. So I have to see that its address is not 0. So that is why I will write this here star. It's not null, I mean. Okay, so then I'll call the same function on the next element. Okay, so and I'll also increment it by 1. So I'll keep calling the same function on the next element till this if becomes false, right. So at that time I will return the last element. Okay, so I have returned r, then I'll go one step up and I'll return I, then so when I return r, this thing, so this thing that is there, this thing, I mean sorry this thing str plus 1 here. So at one point it will become null, right, it's that backslash 0 that will become null. So that is when I'll return r, then I'll go back one step, I'll return. So all this DINOSAU were in store, were waiting in a stack. So since stack is last in first out, I'll first return r, then a, then u, then s, then o, then n, I, then d. Okay, so it is you just carefully analyze this once, okay, and let me know if you have any doubts in the next class. Okay, I hope you have written this down, but anyway this the video of the class will go on YouTube, so you can just pause it then and write that, and just keep your doubts, you can ask them in the forum or to me in the next class. So thank you all, bye. You can